All right. So first of all, if you have this upside down T, that little symbol means, yeah, you should write this down. This little symbol means perpendicular.
No.
You can just put it in the front. That's fine. Okay, perpendicular. So, like, if I have a line segment, so we have A, B. You should draw this as well, and then CD. So you might have something that says segment AB is perpendicular to segment CD. Okay, and if we have two perpendicular lines, what do we know about these angles? They are 90 degrees is what we want to say. So we can state that angle ADC and angle CDB are right angles. Okay? And our reason for this would be definition of perpendicular. All right, so that's a new one we can use now, definition of perpendicular, so we can get right angles, which is going to help us get right triangles. And then, of course, we have midpoint, which we have used before. So if you have midpoint, like if this is segment A, B, and they tell us that C is the midpoint of the segment, what do we know about this and this? Yeah, Tom. Yeah, we know AC is equal to CB. Because midpoint means it's exactly halfway, right? It's exactly in the middle. So if you have a midpoint, we know we have congruent parts. And what would our reason be here? Definition of midpoint. Okay, so use definition of perpendicular and definition of midpoint when you're proving proofs. Okay, the next thing that's really important is CPCTC. So I would write this down, what it means here. No. So CPCTC means corresponding parts of congruent triangles are congruent. So once you prove the triangles are congruent by angle, 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 side, side, angle, side, 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 or HL, then we can state any other angle that we don't already know or any other side that we don't already know is congruent. Because once you have congruent triangles, everything is congruent in the triangle, all three sides and all three angles. Okay, this will be on the test to make sure you memorize what it stands for. So there's two congruent words in there. Corresponding parts of congruent triangles are congruent. Okay, so when you would use CPCTC, it would be one like this. So let's try this one first. And how do I know I'm going to use CPCTC? Because the end of it says, write a two-column proof to prove these two segments are congruent. So we're not proving the triangles are congruent as our final step. We're proving the two sides are congruent. So we still need to prove congruent triangles, and then our last step is, now I have congruent sides by CPCTC. So let's start with what we know. Go ahead and sketch this in your notes. I'm going to state our givens first. So first we know angle 1 is congruent to angle 4. So I'm going to state that. And I'm going to mark it on my picture. So angle 1 is congruent to angle 4. Okay, we have another given, and we got to say given for a reason. So for our second thing, we can say angle 2 is congruent to angle 3, and that's given. So we need to prove the triangles are congruent first. So who can tell me one more thing we know by looking at the picture? Sebastian?
PR and RP are
good. Very good. So we know those sides, they share this side right here, reflexive property. And Pete? Good. If we know 2, we know 3. So angle Q, good, is congruent to angle S, because if we know 2 angles, we know the third one. Okay, now we have congruent triangles, so we have to state they're congruent. Now be careful, when you state congruent triangles, we used to just copy what it had here, but that isn't written this time. When you guys do congruent triangles, you have to go in the same order on both triangles. So if I start with PQR, I need to match up my angles on the other one. So if I go PQR, I have to go RSP. Okay, so triangle PQR is congruent to triangle RSP. So same order. And my reasoning is angle, 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 side. All right, once we get to this, we can state anything else we don't already know is congruent. So we're trying to prove that QR is congruent to SP. And it is true because once we know the triangle is congruent, corresponding parts of congruent triangles are congruent. CPCTC. No. Oops, we have one more here.
Oh, don't worry, it's okay. You can just go to one.
We've got to do perpendicular.
Let's roll.
So go ahead and draw that picture. So this time we're just proving congruent triangles, so we're not going to need CPCTC on this one. And we can go ahead and state the givens. So we've got RP is perpendicular to PS. All right, so RP is this segment right here, and PS is this segment right here. So if these are perpendicular, what can I draw on my picture? A right angle. Okay. And let's go ahead and do our next given. So we've also got that RP is perpendicular to QR, given. So again, we can mark this segment and this segment are perpendicular, so mark your right angles. Once we know that, we need to state that they are right angles. So we can state both of them at the same time, angle QRP and angle RPS are right angles. And the reason is definition of perpendicular. All right, we have one more given. So let's put that in there. PQ is congruent to SR. And that's given. And let's mark it on our picture. PQ, SR. Okay, there's one more thing that we need from the picture. Anybody know? Nope, we don't know the other angle. Sebastian? Okay, RP is congruent to RP. Nolan, what's our reasoning? Okay, reflexive property. All right, so remember that not only do we have to state that we have right angles, we have to state that they are right triangles if we are going to use HL, which is what we're going to use because we've got the hypotenuse given and we've got one leg and it's a right triangle, but we need to state it's a right triangle first. So let's go triangle QRP. And again, when you mark these triangles, if I say QRP, what way do I have to do the other one? SPR. Oops, I meant to not say congruent. There, you guys. This and this are right triangles. Definition of right triangle. Now we can finally say they are congruent.